Welcome to Demystifying Math. In this lesson, we're going to be discussing simplifying radical expressions, and we're going to apply it to using the Pythagorean Theorem and the distance formula. Let's start by simplifying the square root of 135. We need to find a perfect square that is a factor of 135. So we're going to do that by rewriting 135 as a product of its prime factors. Starting with 135, we're going to look for a prime number that goes into 135 evenly. And I'm using 5. 5 goes into 135 27 times. 5 is a prime number, 27 is not. So now we're going to work with the 27 and break it up as a prime number times another number. So a prime number that goes into 27 evenly is 3. 3 times 9 is 27. Since 9 is not prime, we're going to break that up as 3 times 3. So now we have the product of 3 times 3 times 3 times 5 is 135. So I'm going to rewrite 135 as 5 times 3 times 3 times 3, which I rewrote as 5 times 3 times 3 squared. And I did that because 3 squared is a perfect square. And it's 9 actually, and the square root of 9 is 3, so we can actually take that square root. But under the radical we still have a 5 and a 3. 5 and 3 are not perfect squares, and neither is their product, 15. So that has to stay underneath the radical. So we have this 3 square roots of 15 as our final answer. Let's try this one. We have 980, and we want to take the square root of it. So we're going to start with 980 and break it up as a prime number times another number. So I chose to use 2. 2 goes into 980 490 times. So now we want to break up 490 as a prime number times another number. So I chose to use 2 again. And 2 goes into 490 245 times. Now we're going to look for a prime number that goes into 245 evenly, and I used 5. 5 goes into 245 49 times. Now we're going to use 49 and break it up, and 49 is 7 times 7. So the prime factors of 980 are 2 times 2 times 5 times 7 times 7. Now notice that 2 of them are duplicates. So we have 2 squared, and we have a 7 squared, and then we have a 5. So anything that's squared, when we square root it, we're going to get the number that was squared. So the square root of 2 squared is 2, and the square root of 7 squared is 7. You can also think about it this way. The square root of 2 squared is the square root of 4, and the square root of 4 is 2. 7 squared is 49, and the square root of 49 is 7. 5, we can't take the square root of, so it stays underneath the radical. So we end up with 14 square roots of 5 as our final answer. Okay, let's use this when finding the length of a side of a triangle. In this case, we have a right triangle, so we're going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared. With the Pythagorean Theorem, a and b are legs of the right triangle, and c is the hypotenuse. So we're going to plug in the lengths of our legs. So we have a is 5 and b is 10. And we're going to isolate c. So we have 5 squared plus 10 squared, which is 25, plus 100 equals our c squared, or our hypotenuse squared. Always do the exponents before the addition. So we have 125 equals c squared. And then we have to take the square root of both sides of the equation to isolate c. So c is equal to the square root of 125. Then I wrote 125 down as a product of its prime factors, which is 5 times 5 times 5. Or you could say it's 5 squared times 5. So using the first two 5s, we have the square root of 25, which is 5. And then we still have another 5 left underneath the radical. So the length of c is 5 square roots of 5 centimeters. For this problem, we need to find the length of a missing leg. So we're still going to use our Pythagorean Theorem. Our c is 6, and our side a is 4. Our side b is the unknown, so we need to isolate b squared. So first we're going to square, so we have 16 plus b squared equals 36. Then we're going to subtract 16 from both sides of the equation, so we get b squared equals 20. Now we're going to take the square root of both sides of the equation. So we're going to rewrite the square root of 20 as a product of its prime factors. So that's 2 times 2 times 5, or you can think of it as 4 times 5. The square root of 4 is 2, and the square root of 5 is square root of 5. So you have 2 square roots of 5 for the length of side B. Next, we're going to find the distance between 2 points on the coordinate plane. So we have the points -1, 7 and 5, 5. The first thing that I'm going to do is plot them on the coordinate plane, draw a segment between them, and that gives me segment AB. Then I made a right triangle out of that, so I dropped down a line that's parallel to the y-axis and one that's parallel to the x-axis to form the right triangle. Now I need to find the lengths of the sides of the lengths of the sides of the triangle. So looking at this length here, going from C to B, that would be the difference between my x values, which is going from -1 to 5, which is the length of 6. And I can get that just by looking at the coordinates by taking 5 and subtracting -1. 5 minus -1 gives me 5 plus 1, which is 6. Now this length here, AC, of the right triangle, can be found by finding the difference between the y values. So those values are 5 and 7, and we're going to subtract those, and we get -2. It's actually a +2, but it really doesn't matter because we're going to square it. Okay, so we have a squared plus b squared equals c squared. Our side A, which is opposite angle A, is here, which is CB. So we're going to plug in the 6. Our side B we got is -2, which we're going to plug in for B and square it. And then what we're going to do is isolate C. So we have 36. -2 squared is +4, so that gives us 40. Then we have to take the square root of both sides. So I rewrote 40 as 2 times 2 times 2 times 5, which you can think of 8 times 5, but since 8's not a perfect square, it's better to break it up as its prime factors. So we have 2 times 2, or 2 squared, and the square root of that is 2, and we're left with 10 underneath the radical. So the length of side C, or the distance between our points, is 2 square roots of 10. Okay, here's our second example on distance formula. So we have these two ordered pairs at -4, -3, and 6, 9, and we want to find the distance in between the points. So we're looking at the difference between our x values as being this horizontal length here of the right triangle. And if we subtract 6 minus -4, we get 10. And for our difference between our y values, that's this length here, we're going to do the 9 minus -3, which gives us 12. Now, usually we use the Pythagorean Theorem, but we want to change this to a distance formula. So notice that side A is the difference between our x's. So we replaced it as x2 minus x1, and we're going to square it. And our b length is really the difference between our y values. So we have y2 minus y1 replacing b equals squared equals d. Now usually we use c when we're using the Pythagorean Theorem, but when we're finding the distance between 2 points, we usually use d. Then to isolate d, we took the square root of both sides of the equation. So we have the square root of x2 minus x1 all squared plus y2 minus y1 all squared equals the distance between the points. And that's what we call the distance formula, and you can usually just start right there and plug in your numbers. So now we're going to plug in. So for our x2 minus x1 we found 10, so we plug that in. And for y2 minus y1 we found 12, so we plug that in. Then we're going to square, so we have 100 plus 144. Next we add, and the last thing you do is take the square root. So we had to write 244 as a product of prime numbers. So it's 2 times 61. And the square root of 2 squared is 2. And we have square root of 61 left as our distance in between our 2 points. Okay, thank you for tuning in to Demystifying Math.